Hey, good morning, everybody. It's Matt. Gabi sent me a couple questions the other night. I know she's got a test coming up, so I figured I'd run through them real quick, and hopefully this will help a bunch of you guys out. Um, about factoring, um, if you guys don't remember what factoring is, we'll start with like a real basic example. The factors of 6, um, 2 times 3, right? And there's other sets, right? We can say 6 is 1 times 6, or we could say 6 is even -2 times -3, and we could say the factors of 6 is -1 times -6. Okay? So what we're looking for is, excuse me, um, numbers, sets of numbers which multiply to make another number. Okay? So we would say that 2 and 3 are factors of 6, as are 1 and 6, -2 and -3, -1 and -6. Um, Numbers should have more than one factor, so if we said 24, sure, it could be 1 and 24, and 2 and 12, and 3 and 8, and 4 and 6. The convenient thing to notice is if you kind of do them in order, these are going one way, and these are going the other. And when you kind of reach this middle ground right here, you know that you can stop. Okay. And again, because it's a positive number, these could all be negative as well. Okay. Numbers have 3 factors. So just for example, 24, I won't go through all of them, but say, for example, 2 times 3 times 4 makes 24, because 2 times 3 is 6, and 6 times 4 is 24. So it doesn't have to be limited to 2 numbers. In fact, we could even break this down further and say that this is 2 times 3 times 2 times 2, which is the prime factorization, which we'll save for another day. Every number is either a prime number, like 2 or 3, or is a unique product of a set of prime numbers, like these guys. Okay? So what does this mean for us? Like, why do we have to do factoring? You have to do factoring because if you have something like a quadratic, you can't solve this by kind of conventional methods. Normally, you'd want to go ahead and subtract 2, right? We're going to try and isolate the x. We get x squared plus 3x equals -2. But then we kind of hit a roadblock because no matter what, we can't isolate an x in the same way we did for linear equations. It just doesn't work. I could take the square root of this. I have x is equal to, well, I can't go any further than that. So there's no way really to get an x isolated just on one side. So we need a new way to do this. And we're going to do that by factoring. Essentially, I'll show you guys how to do this one real quick. Okay, this is the most basic example. What you want to do is you want to get it, so this is a set of factors. I'll go over how to do that momentarily. This is x plus 2 and x plus 1. Okay? Well, if you guys recall, factors are 2 numbers or 2, things that multiply to make another one. If I multiply this and this together, I will get this. And just to show you that, we can FOIL it. We can FOIL this thing. We say x times x is x squared plus, oops, I'm sorry, plus x plus 2x plus 2, which is x squared plus 3x plus 2. And again, I'll get into how we get from here to here in a second. What I do want to talk about is why this works for us. Okay? The first thing you have to understand is that anything times 0 is 0, right? Anything multiplied times 0 becomes 0. And that's our first point, is that whenever we're solving these, we want to set the whole thing equal to 0. We're going to use that idea that any number times 0 is 0. So for example, this one factored, right? Well, if this factor is 0, right, whatever makes this whole thing right here, whatever makes this whole thing 0, it doesn't matter what this is. Like, who cares? Because anything times 0 is 0. So if I went ahead and I did this and I said x plus 1 equals 0, Well, I find out that x equals -1, okay? And if I go ahead and plug that in, -1 plus 1 times x plus 2 equals 0. Well, this is 0, and again, it doesn't matter. You know, I can plug in the -1 over here. It doesn't really make a difference. -1 plus 2 is going to be, 2, and of course, this is still a true statement, okay, because 0 equals 0, okay? And we can say the same thing for the other one as well. It doesn't matter what it is. If I say x plus 2 equals 0, I'll go ahead and I'll subtract from both sides, and I'll find out that x equals -2. Okay, and those are your two solutions. There are always two solutions, depending on how far you are in math. There might be, 0 or 1 solutions, but there should be two solutions, and that's indicated by the highest exponent. Okay, sometimes they'll be imaginary or complex. Sometimes they'll appear to just be one. There's always two, just depending on what level of math you're at. Okay, so let's get to how I went ahead and I got those factors. First, you need to know, you need to know a little bit something about these. These are quadratics, okay? So quadratics always come in this form, ax squared plus bx plus c. And you want to set them equal to 0, okay? If you guys remember, it was y equals mx plus b. That was for lines, right? Well, this is your new one. It's y is equal to, and I moved over for a reason, ax squared plus bx plus c. And if you notice that all we've really added is this x squared. We changed the letters a little bit, so don't worry about that. But we now have this ax squared. Well, if we didn't have that ax squared, again, I know the letters are different, but it's something times something plus something. And this is so something times something plus something. So all that's new is this ax squared. But what that does is that raises the number of answers from 1 to 2. And if you get a little bit further into this and you start graphing, you'll kind of understand why. But again, they're all going to be in this form. You're going to have something times x squared plus something times x plus something. And again, the pluses could be minuses. Remember, adding negative numbers is the same thing. So they're always going to come in this form. We call this standard form. If you kind of think about it as your exponents, I have x to the second, x to the first, and x to the 0 power. So anyway, what you want to do is you're going to want to find, first of all, you need to check this. Is this 1? You need this to be 1 for this method to work. If this is not 1, you have to do something else. All the problems Gabi sent me, it's either 1 or you can make it 1. Okay. Once you realize that's 1, the next step, you want to factor your C term. You're going to find the factors of the C term, okay? And what you'll do is you'll add those up and find out which ones add up to B. This is essentially reducing FOIL. All right, so let's see what this looks like. In our example, we said x squared plus 2x plus 3 equals 0, okay? Well, the first thing we said was we wanted to find the factors of the C term, okay? So here, A is equal to 1, so that's good, that's step 1. B is equal to 2, and C is equal to 3, okay? Really straightforward. I usually tell my students to kind of set it up like this, where I listed my factors over here, okay, I listed my A, B, and C over here, and now I'm going to list my factors over here. So all my factors of my C term. So C is equal to 3, okay? So I only have 2 sets of factors. I have 1 times 3, and I have -1 times -3. Okay, those are my 2 options, okay? What I want to know now is which one of these adds up to my B term. Oh, I got the numbers. Jesus. I got the numbers backwards. Don't listen to your math teacher. He doesn't know what he's talking about, okay? Excuse me. Sorry. Mistakes happen, guys. I'm sorry. I wrote it backwards. It's early in the morning, if you guys couldn't tell. I'm sorry. A is equal to 1, B is equal to 3, C is equal to, I should have just stuck with the example. I'm sorry, guys. But again, we want to find the factors of C. What are my factors of C? My factors of C are 1 times 2 and -1 times -2. What I want now is I want the factors of 2 that are going to add up to 3, and this time it works, okay? That other one, by the way, that I just made a mistake on, you couldn't factor that over the integers. You'd have to have another way to solve that, and there's 4 other ways to solve these that I can think of off the top of my head. So these are my factors. Okay, I want the factors that multiply to make this number and that add up to make this number. This will essentially reverse your FOIL process. So anyway, so what you'll do is I'll break this down. Say x plus 1, which is a positive 1. I'll say x plus 2. This is a positive 2. Okay, and there's your factors right there. And then, like I said, from there, you're just going to go ahead and you're going to solve it. Subtract your 1s. X is equal to -1. Subtract, and then x is equal to -2. So those are your 2 answers. Okay. Sorry, it's negatives. And again, you can go ahead if you want to check. You can plug those back in here, and they will work down below. Okay. All right, so I know I've kind of gone a little bit further than I wanted to go here. I'm sorry again about the mistake. I'm going to run through a few examples that Gabi sent me, and we'll see how that goes. So this is your first one. So this one right off the bat is a little unique, okay, because a equals 1, b equals 1. This is ax squared plus bx plus c. There is no c term, so c is actually equal to 0, okay? All right, the first thing I want to tell you guys, okay, whenever there's no c term, one of your answers is 0, okay? Because if you think about it logically, this one is equal to 0, right? If I plug in 0 squared plus 0, that equals 0, okay? So by default, when there's no c term, one of your answers has to be 0, because there's no c term, there's no constant to be added or subtracted, okay? So we're going to factor this one a little bit differently than we factored the last one, okay? So the first thing you want to do is say, do my terms all have something in common? Yes, they have x in common, okay? So what you can do is you can factor out an x. You're reversing the distributive property, okay? So I'm going to factor out an x. Well, that means I have to divide all these things by x. So x squared divided by x is x, and x divided by x is going to be 1, okay? And just to show you guys, if you would reverse this process, okay, you're just undoing the distributive property. There's no big deal there, okay? So again, here's my 2 factors. Well, again, if x equals 0, there's your first one right here. Okay, and your other one says x plus 1 equals 0. And subtract 1, and x will equal -1. Okay, so those are your 2 answers. And again, if you want to plug these in and make sure it works, you can go ahead and plug it in. I say x squared plus x equals 0. We already did one for 0, so we'll say -1 squared. Be careful how you put this in your calculator. Plus -1 or -1 equals 0. Well, -1 squared is 1, and 1 minus 1 all day, every day equals 0. Okay. So again, there's your 2 answers. They should have 2 answers. Sometimes they'll appear to have 1 answer or even no answers. But again, your highest level exponent should let you know. Oh, I don't need to raise this. Okay. Your second example is pretty much what we looked at in the first one. We're going to try and solve this by factoring. So the first thing you need to do is you need to set it equal to 0. It's got to be equal to 0. Oh, we're writing in red now. We have to set it equal to 0. So that x squared minus 3x minus 10 equals 0. Okay? So just subtract 10 from both sides. It's basic algebra. Okay. So this one, again, we have a trinomial. So I would say a is equal to 1. So we can proceed. So this is, again, there's an invisible 1 there that we don't write. But it's there. So we can proceed. B is going to be equal to -3, and C is going to be equal to -10. Okay. So what I want to do now is I want to find the factors of C that add up to B. Okay. I know a lot of you guys are going to scream what they are, scream while I'm doing this, but that's okay. So C is equal to -10. What are my factors of -10? Well, I have 1 and -10 and -1 and 10, 2 and -5 and -2 and +5. Okay. So the ones that add up to -3 are going to be these guys, right? So these, again, are the terms that multiply to make your C term, but add up to make your B term. So you can start out always, just write it out in your plain old factored form. Okay, so x and x, okay? And then you just go ahead and fill these numbers. And you fill in +2 and -5. Okay, we're going to set those both equal to 0. X plus 2 equals 0. X minus 5 0. Okay, again, I know a lot of your impulses are going to be just to go ahead and switch the signs of the numbers. Please don't do that. Please just don't say, oh, it's positive 2, it'll be negative 2, or oh, it's negative 5, it'll be positive 5. That's true here, but eventually what's going to happen is when there's not a equals 1, you can't do that. But again, that's a little more complicated. We'll get to that a little bit later, okay? Oh, we're past the 15-minute mark. Okay, last one. This one right here. Well, again, we're running into a different problem. We have an A term, and we have no B term. So right now, A is equal to 2. B, I remember it's bx, right? So there's no bx term here. So we have no B term. So that's going to equal 0, which is okay. It's no big deal. And C is going to equal negative 18. Okay, so a couple things. First of all, you can actually solve this one your old school way. You just have to remember a couple of things, okay? So I'm going to show you guys one way to solve this way. Like if you ran into a problem like this and you had a brain fart on the test, like you just didn't know what to do, you can kind of solve it and then go back and give it to you how your professor wants it. And so you can go back again. Oh, I get 2x is equal to 18, right? And you can actually solve this, but you have to remember something. You have to remember that when I take the square root of this side, okay, that becomes x. This has two answers. The square root of 9 is positive and negative 3, okay? Because 3 times 3 makes 9, but so does negative 3, okay? So again, those are going to be my answers. Positive and negative 3 are going to be my answers, okay? So another thing is if you guys don't have a b term, the b term is equal to 0, you can still solve this way. So just keep that in the back of your mind. We're gonna solve it by factoring. But just in case you had a brain fart, you couldn't figure it out, okay, if you have no b terms, it's a cool trick to remember. So again, if you have no c term, 0 is automatically one of your answers. If you have no b term, you can go ahead and you can solve it the way you used to. All right, so the first thing you want to do is you want to determine, well, we said that the first thing we want to check is if our a value is equal to 1. It's not. My a value is equal to 2. The first thing you should do, especially if you're not out of Algebra 1, not out of Algebra 1, if you're not out of college algebra, not out of college math, see if your a term divides into everything. In this case, it's 2. So yes, it does. 2 goes into 2, and 2 goes into negative 18. So I want you to do, before you even start, go ahead, factor out the 2. Okay, so this is going to become x squared minus 9 equals 0. Good? And again, whatever makes this thing in here 0, we'll make the whole thing 0 because it doesn't matter, because it'd be 0 times 2, and that's still 0. So I don't want to tell you guys the wrong thing to do, but you can pretty much ignore this. You can ignore it. You can give it the cold shoulder. Who cares? It doesn't have any influence on your answer. So now we can factor this, though. Okay, well, a is now equal to 1, b is equal to 0, and c is equal to negative 9. Well, what are your factors of negative 9? Well, I have 1 and negative 9, I have negative 1 and 9, and I have negative 3 and positive 3. Well, lo and behold, we do have a set of factors that adds up to my b term. We have a set of factors that adds up to 0. So you're going to go ahead and you're going to write this. Don't forget to rewrite the 2, even though it has no impact on your answer at all. I have x minus 3, x plus 3, and that's equal to 0. Okay, so you can split these into 2. So x minus 3 equals 0, x plus 3 equals 0. Okay, and again, whatever makes these 0 will just be multiplied by the 2. So the 2, again, will just get canceled out. 0 spread like the plague. So I'm going to add 3. We'll have x equals 3. I'll have x equals minus 3, which we knew right from the get-go was our answer. So again, if you remember how to solve the other way, just kind of go back and fiddle with the numbers until they work. Okay. I'd be a bad math teacher, which I probably am a terrible math teacher, but I do want to talk to you guys about this because this is a unique case. Okay. So I'm going to write everything, and I'm going to leave it right smack in the middle. Okay, this is what we're going to call the difference of two squares. This is the difference of two squares. Well, why is it called the difference of two squares? Well, it's a difference. Right, there's your difference. Okay, and then you have these are perfect squares. Okay. So anyway, if you're done and you got it, feel free to ignore this. But again, I'd be not doing it justice and not explaining what this means real quick. These are perfect squares. If you guys don't remember what perfect squares are, your perfect squares are 0, 1, 4, 9, 16, 25, 36. Okay. All the numbers you can take a square root of and get an answer. I thought when I explained this to Gabi on the phone the other day, she had a fantastic answer. She was like, they're the ones I put in my calculator and they give me a number, which I thought was great, okay? So again, remember this is positive negative 6, positive negative 5. Okay, big thing is you have to remember that there's two answers, positive negative 4, and 3, 2, 1, 0, okay? But also remember, x squared is a perfect square too, right? So I can take the square root of x squared, that's x. If I said x to the fourth, that's x squared, right? Because x squared times x squared makes x to the fourth. If I said, I don't know, 16 x squared, well, the first 16 x squared is 4x, okay? So anything that's essentially got an even exponent, you can take the square root of, and then if there's a coefficient in front, if that's a perfect square, then the whole thing's a perfect square. But if you can recognize this, that this is a perfect square, this is a perfect square, and they're subtracted, it's a pretty straightforward process. It's always going to be the same format whenever you factor them. Okay. We would go ahead and say, well, positive 3, negative 3. Okay. And that's pretty much the square root of the first one, the square root of the second one, and then one's positive and one's negative. Okay, that's it. So the square root of x squared is x, the square root of 9 is 3. Okay, and all you got to do is make sure one is positive and one is negative. Also, just for your own edification, okay, look, no b term, right? No b term, very easy answer. This again is one of those ones you can actually solve using your regular old school methods. You just have to remember there's a positive and negative answer. All right, well, it's now 8:10 in the morning. I've been talking for 22 minutes and I need a cup of coffee. I'm expecting Gabi to send me some more questions this week, so good luck, and I'll talk to you guys soon.